Welcome dear students. Let's continue with the second exercise, that is exercise 13b on Pythagoras theorem. Today I am starting question number 5. Okay, so let's look at question number 5. So question says, in triangle ABC, angle B is 90 degree and D is the midpoint of BC. Prove that AC square is equals to AD square plus 3CD square. Now what's the meaning of this? That can be understood only with the use of a diagram. So there's a triangle ABC with angle B 90 degree. Okay, so you see angle B is 90 degree out here, and it is given that D is the midpoint of BC. So D is the midpoint of BC, that is given. Now you need to prove all this particular identity, right? So how to prove this? So let's start. Okay, so first and foremost what we'll do is we'll join AD. Okay, so we'll write what is line AD. Now since D is the midpoint, then we say that BD and DC or CD, they are equal, isn't it? Right. Now if you observe triangle ADB, okay, so in triangle ADB, so we are talking about this triangle. Now in this triangle, this is 90 degrees, so side opposite to this, that is AD becomes your hypotenuse. So that's why you have AD square is equals to AB square plus BD square by Pythagoras theorem. Okay. Now from here, what is AB square? From here, AB square is, so bring this out here, you get AD square minus BD square, and let me call this to be equation number 1. Okay, so this is my equation number 1. Now we will consider another right angled triangle. So forget about this AD. So that time you have ABC, triangle ABC is a right angled triangle. Now in this, AC becomes your hypotenuse. So that's why you have AC square is equals to AB square plus BC square. So from here also we'll find AB square will be equals to AC square minus BC square. Call this as equation number 2. Okay, now see, we have AB square here also we have AB square. So using 1 and 2, can I say that the right hand sides are equal? Because in the left hand sides we have AB square, so that's why the right hand sides will be equal automatically. Okay, so we have AC square minus BC square is equals to AD square minus BD square. Okay, now what I have done here is, let me take this out here. Okay, so it becomes plus BC square. Okay, now you know BD and CD, they are equal. BD and CD are equal, and they are actually half of BC, isn't it? BD and BC, they are equal, and they are exactly half of BC. You know that. Okay, so that's why in place of BD and in place of BD, what am I going to write is, I write half BC. Okay, see here carefully. Or what you can do here is, okay, so this BC is there, right? See here carefully. BD is written as CD. Okay, so BD and CD, they are equal, so that's why in place of BD I have written CD. And BC, so from here, can you see that BC is 2 times CD? Yes, so because see, you know that BD is half of BC, or in other words, can I say that BC is double of BD? Obviously. So similarly, BC will be double of DC or CD. So that's why in place of BC, you can write double of CD, and from here what will be BC square if you square both sides, because we have BC square, right? So from here BC square turns out to be 4 CD square. So that's why in place of BC square I have written 4 CD square. Okay, now CD minus CD square plus 4 CD square, how much is that? That is plus 3 CD square. Simple. So that's what we are asked to prove here. Okay, so you may pause the video and note down your solution. Let's move to the next question. So in a rectangle ABCD, you see ABCD is a rectangle, we need to prove this. Okay, so ABCD is a rectangle, as you can see from the diagram. Okay, now all of you know that all the angles of rectangle, so this angle, this angle, this angle, and this angle, angle B, all of them will be at 90 degree in a rectangle. Okay, so what am I going to do is, we'll see triangle ACD. Okay, so in triangle ACD, just look at this triangle ACD. Since this is 90, so side opposite to this becomes your hypotenuse. So that's why you have hypotenuse square, that is AC square is equals to base square plus perpendicular square. Okay, or perpendicular square plus base square. Perpendicular is AD or DA and base is DC or CD. Okay, now call this as equation number 1. Similarly, we will apply Pythagoras theorem in triangle BDC. So look at BDC. BDC is this triangle. Okay, here we have 90 degrees, so side opposite to this, that is BD, becomes your hypotenuse. So that's why you have hypotenuse square is equals to perpendicular square plus base square. Okay, now you know in a rectangle opposite sides are equal. So that's why can I say that CD is equals to AB? CD is equals to AB, obviously. So that's why in place of CD I am writing AB. Okay, and call this as equation number 2. Now adding 1 into, let's see what do we get. So in the left hand side we have AC square plus BD square. Okay, and the right hand side we have, first we will get DA square. Okay, but as per this, what am I going to do is, I'll write in alphabetical order or given order. So first we will write AB square. Okay, then we will write BC square. Okay, then we have CD square, and at last we have DA square. Okay, so when we add equation 1 and 2, we will get the thing that we need to prove here. So you may pause the video and note down your solution. Let's move to next question. So in a quadrilateral ABCD, angle B is 90 degree and angle D is also 90 degree. We need to prove this. So first and foremost, we will draw the respective diagram. Okay, now look at this. If you look at this diagram, we have both, we have both angle B and angle D given to be 90 degree. Okay, now what I have done here is I have joined the diagonal AC, or I have written the diagonal AC here. Okay, now in triangle, in quadrilateral, you know this, right? So this is already given. Now can you see that this triangle ADC and ABC, they are right angled? Obviously, because one of the angle is 90 degree. Now let's apply Pythagoras theorem in this triangle ABC. So this is 90, opposite to this is AC. So that's why from Pythagoras theorem, AC square, that is hypotenuse square, will be equals to AB square plus BC square. Okay, now from here what will be AB square? AB square will be AC square minus BC square, and call this to be equation number 1. Now similarly, we have another right angle triangle where again AC will be your hypotenuse, right? And let me call this to be equation number 2. Okay, so in the left hand side, just look at the left hand side. In the left hand side we have this one. Okay, now put the value of AC square using equation number 2. Okay, or you can write this as it is for now. Keep AC square as it is. Now AB square using equation number 1, in place of AB square, can I write AC square minus BC square? Definitely. Now open the bracket, so you get minus AC square, minus into minus becomes plus BC square. So 2AC square minus AC square is AC square plus you have BC square. Okay, now from 2, just look at equation number 2. Can I write AC square as AD square plus DC square? Yes, so AC square is written as AD square plus DC square using equation number 2. Okay, and that's what we need to prove, isn't it? See, in the right hand side, what do we have? We have BC square plus CD square plus DA square, and we have here in place of DA only AD is written. Okay, and in place of CD it is DC written out here, and this is what I need to prove actually, right? So you may pause the video and note down your solution.